Okay, some student in the past you already know how to do what to do. That be fine. Be patient. Okay. The thing we get more new student, I try to speed it up. So in order to do the lab, okay, first thing you must get this thing. Make sure in your computer, in C drive, you must have a directory ETT. If you don't have it, then you have to create one. And inside that directory, you must get that file, io.h. That will be C++ header file. And also, you're able to run the pspy in the computer, on your computer, okay? And the last thing is the Visual C++ program must be already installed in the computer. Those are the requirements in order to do the digital lab in this program. If you already have everything, good. And any student get any question or anything?
We're good.
So look like you guys already get everything, right?
Yes, sir.
Okay. Now, next one. For the DLAB, normally they given you the schematic. And if you're looking on the schematic here, and the input of the circuitry will be 1, 2, 3, 4. Okay, and the output will be 2, PC0102. Okay, now, first thing we have to do until you get it passed in here. Okay, and to do the lab, you can using the PSPI simulation. And that simulate, they given you the input signal, and they will be giving you the output signal. That means you don't have to analyze the circuitry. I given you the example. If you get a 0, 0 here, output NAND gate will be a 1. And that will be a 0 here, and you get a 0 here, output will be a 0. 0 and 1, output will be 1. That will be analyzing circuitry. Okay? And basically, we cannot do it. Okay? Then we need the simulation. Do it for you. You given the input waveform. And when you run simulation, they given you the output. So we get only not the lab using simulation program. Later on will be more easier if you understand how they're working, then you can, testing. The thing is simulation program have not enough part in the library. So that's why, okay? And now everything in here if you're reading, okay? Now, if you get the input-output to table, you get an input here, what the output when you run simulation, you enter it, okay? This is the signal look like you given you the simulation program. For example, PA01, if you're looking on that thing here, PA01 right here. So they get a 01, 01, 01, 01, and so on. The computer cannot recognize 0 and 1. However, if you get a waveform here, they are able to recognize you get 0, then 1, 0, then 1. Okay, and so on. Okay. PA number 2. So you get a 0, 0, 1, 1, and so on. Okay. That's what you need to give into your input to the simulation. Then they given you the output here, and you record that. Okay. After that done, then you can go to the quiz here. That's a simple one. Okay. That means they have asking you how many input of the circuitry, then you enter here. How many output, you enter here. How many gate in the circuit. So now if you're looking on the circuitry here, can you tell me how many gate?
5 gates.
5.
5 gate. 1, 2, 3, 4, 5. How many IC using for this lab?
5 still.
1. 1.
4.
Now,
Yeah, 4.
okay, easy to recognize. Normally company using yield.
4.
Yeah, yield means unit. You get along with that one when you get to the company you don't have, you're not surprised. Okay?
So how many ICs are there?
Not yet. Okay. Company using yield mean yield what? Okay, don't have a B, C, D. Okay? On the simulation, you get A, that means the first gate. B means the second. If you want to know how many IC, just count on yield. Yield 1, yield 2, that's the 2. Yield 3, and yield 4. That means 4 IC. The first one, the part number 7400. Second one, 7432. 08 and 86. That's the 4. Okay? And they get 5 gate be yield. Okay? And now, what pin connect to VCC? What pin connect to the route? So for the IC 7400, for example, what pin will be connected to the 5 volt?
Pin 14.
14. If you're looking in the handout, okay, then pin 14 must be connected to 5 volt. Which pin connect to the route?
Pin 7.
Pin 7. Okay? That coming from your handout. And also they can asking you how many gates inside IC 7400. 7400 here. How many gates inside?
1.
4.
Oh, you have to looking into your handout. for the part 7400 NAND. Inside they get 4 gate. The first one will be pin 1, 2, 3, and the next one will be 4, 5, and 6, and so on. Okay? 4 gate inside one IC. Same thing for 32 or 86. Okay? So that is easy to get through that one. Now, the next thing is in the system, they get a port A, port B, port C, port D. Each port will be 8-bit, 1, 2, 3, 4, 5, 6, up to 8. Okay? You see that? Port C, same thing. 1, 2, 3, up to 8. Depending on the lab, which port they using. Okay? So after you done for this one, so now you can see you get a port A, pin 1, pin 2, pin 3, pin 4. So basically, I can copy that guy here. Okay? Control C, copy. And I go to port A, B, C, D here. Okay? And pin 1, 2, 3, 4. Okay? I paste them out. That means the input will be applied. Now, these are the input to be applied to the simulation. However, to the program, you need to convert into the hexadecimal. Okay? So on the hexadecimal, you have to enter in the form 08. 08, that tells the computer you're using Visual C++. And then what the number in the hex here? The one you're not using, that means they will be 0 anyway. So can you tell me what the number here converting to the height?
0, 0.
0
0x0.
x 0.
0, x 0, 0. Right?
Yes.
The thing is 4-bit in a binary converting to 1-bit in the hex. Okay? So the first 0 here for this guy. And the second 0 for this one here. What that one? Next one. 0, x what?
0, 0,
0,
0,
1.
1.
Perfect. 0, 1. Okay? And so on. That means we have to finish that after you get this done. Okay? Everything done here. Now, after you can done for this one, you go to the port C. Port C, they're using only pin 1 and pin 2. Okay? Now, you going back here. You must get this done after the simulation. Then you can copy that one, paste it into here. Okay? Now, in here, after we done simulation, I will be show you more detail on this thing. That means we have to complete everything we need here. After you're doing a simulation, everything, if you get a part in here, okay, then we don't care anything about this circuit here, don't care about that thing, nothing. However, in order to write a program, only thing you will be need only on port A and C here. That means you want to converting from A and C into your program. So when you try to code in your program, only thing you want to see will be here. Okay? So that is a process in order to complete the software and everything, except, you can build the circuitry and then run your test program. So now we will be talking about the simulation. First thing you want to run the simulation, you must be get into your PSPI, right? That's a PSPI, okay? Then you can see what you need in here. You need 7400, 7432, 86, and 08. So basically, you already know how to do on the simulation, okay? Okay, so first thing you go into raw, get, new path. Okay, you want 7400. Okay, plug that one here, only one. I don't care, I don't need anymore. And 7408. Two. And 7432. Let's see. 28, 32. Oh, okay. And the last one will be 86. Okay, what else we need? Okay, now we need that guy. You know what the name?
Source.
Global.
Connector here. You know which one? If you don't know.
Somebody just said it.
Global. Is it
Global.
global? Yeah.
Global. The global right here. See that? Okay. You're pressing here. Okay, let's see. What else? That one you already done. That one you already done. Now we need one more. Include. Okay, so include GSI. Okay. Okay, that's what we need. Okay, I can move that one, go into here. I can move that guy, go to here. And move that, go to here. Okay, now what you need to do is go ahead and draw the circuitry for me. Make sure I put only one here. If you want more, just make sure they turn red and Control C, Control V. You can get any as much as you can. Okay. If the gate, the same thing. If you get 2 gates, then you have to make it red and Control C and Control V. Okay. So can you think you can draw it? Like that one, you get N, or. That will be NAN, or N. So the first one, you think you get NAN here. Okay. And another one will be OR here. Okay, that will be N. Okay, we move that guy. And now it looks it OR. Let's see how they will be look like. Okay. So inclusive OR will be going here. Okay. And you get another one to Control C, Control V. Okay. You can get another one here. Okay. Now, this is one. And the next one will be U2, then U3. Okay. We can change that. Okay, U1 now, that will be U2. Change it to U2. How come we cannot change it?
You got a U2 already.
Double click it.
You got the U2 already named, so you have to
Okay,
name
but
to something else first.
when you click it, you're supposed to change. Can you change that? How come I cannot?
No.
Mine won't work.
Is it working?
Mine won't work. Double click on the U3A, click it, and then double click.
Yeah, that's what I left to click. How come they not so?
Mine
Delete it. Double click and delete it, maybe.
See?
Yep, doesn't work.
How come they not working? Everything. Even I'm click the IC, they not.
Could it be that that little pop-up window is opening on a different monitor? That has happened to me before. Like it's hiding somewhere. It opens, but you can't see it because it's hiding either on a different monitor or like below a window.
Oh, okay, I see what you're saying. That may be a problem. That the thing I using to monitor. Okay, let's see. I try to save it. Okay. Doesn't matter what I will say. Okay. Then now I get out. Let's see. And I try again. See, some really get something going on. Okay, so I send it to you too.
Will they let you?
Yeah, they're working now.
Oh, okay, yeah.
Okay, that one sent to you 3. Something hang up. Okay, and that we send you 4. That you 4. Okay, so U1 okay, U2 okay, U3 okay. However,
You can be in here. You be on the bottom.
yeah, U4 you get 2 gate. This is you using the number 1, then that have to be number 2.
Number 2, but really number B.
Yeah,
Not A.
right. That's what you change it from A to B. You can see in here they get 4 gate, A, B, C, D. We already using A. And now we change to B, automatically they change the pin number. Okay, so basically that will be done for around the circuitry. Now we need to get the connector. That one here. 1. Okay, I make a copy, paste them out. I get another one, 2, 3, 4. Okay, and I try to see how they be look like. Okay, I bring it to another one here. Okay, pin 1, pin 2. So that's why we go to the 4th one, go to pin 1, pin 2. That will be 2. Okay, then 3, 4. That will be 4. That will be 3. Okay, so now we can connect the wire. Okay, you go to draw wire here. 1, 2, 3, 4. Okay, so basically that one here goes to pin 1 here. Okay, and also go to pin 1 of this guy. Okay, and this pin 3 go to pin 5. So I need to move that going up. Right here, and they will be able to here. Okay, and this one here, and this one here. Okay, now this one you need to rotate it. 1 and copy paste them out. Okay, now you assign the number here. Double click on that. Okay, typing PA.01. And that will be PA.02. PA.03. PA.04. That will be PC.01. And that one, PC02.
Mr. Pham,
Yeah.
what is this part called PA01 in the PSpice? G1, what was that? I forgot. How to pull out this part from in the PSpice?
Global.
Oh, P1 global. Thank you. And one more question: is PA1 and PA and PC are different? Am I right?
Yeah, PA talk that depending on port A on the system.
No, but from the PSpice part, are we going to just take a global? Am I right? GA global, and then the same is there for PA and PC. Am I right? Or different?
No, it's not different. Different is the name.
Oh, name is different. Otherwise, the part is same. Okay, that's fine.
Okay.
What you do is you click on global, and once you get global, then you double click on global and type in what you want.
Thank you, Mr. Smith.
Okay, so that is you already complete your drawing the circuit. Okay. And now the next step will be you have to tell the input to your simulation. So the first thing, double click on include here. Okay. And basically click on a file name and you can typing in C drive slot, okay, ETT. That means ETT slot, okay. You can say DLAB01 dot at the end. That's only telling you get the file name DLAB01 extension STM inside the directory ETT. And now
What's the extension? Can you repeat one more time? It's so small I cannot read.
STM. STM.
Thank you.
And you can save it. Okay.
Mr. Pam,
Yeah.
does it matter if the first logic gate is 7401 on the Excel it's 7400?
74, you're talking about 7400.
Yes, yes. The one that is on your PSpice is 7401.
Let's see, how come they be NAND gate and they be 7401? They're supposed to be 00. You see,
Yes,
this
sir.
is a NAND, right? This gate here is a NAND.
Yes.
Okay. I try to get another NAND. I say this one first, okay?
Okay.
Okay. If you're doing the right thing, then you can say they display C column here, the bar over ETT means directory of ETT, and this is the file name. Okay. I try to get another NAND here. How come 7400 here? Right?
Yes, sir.
How come they look like the same and it's 00 and 01? I don't know. Okay, I delete this guy. Turn that red, DL, delete it. And now I can put that in here. However, this one is U6, I don't want it. I want U1. So double click, change it to U1. Okay. Now I can say, okay. So now the problem here, that means you have to edit this file. Okay. When you double click, okay, you double click and they asking you whatever here, then you must be say yes, okay? Do you want to create a new file yet? Okay. Let's see. Any notepad here. Okay, when you click yet, and they given you the new one file, nothing in there. Okay, and now you have to enter. That means you have to type it. Okay, like we say right here, the signal will be look like that one. PA go 01, 01, 01, 01, PA 0011, so on. Okay, so now what I can do, I get the file already. Okay, this is the file already here. I can copy that and paste them out. We will explain to you how they work. Okay, Control A, right? Okay, then Control C. Okay, and now paste them out. Control V. Okay, I try to explain to you. The first line here, you see they get
Can you repeat how you got this file? From where? I didn't follow.
That means the file already, I have already there somewhere in my computer.
Is it on a C drive? We give the path?
So we don't have that file yet.
Okay.
Oh, okay.
Okay, I show you.
What happened is after you guys do a certain amount of experiments, then you'll have a bunch of them. But for right now, you probably don't have them.
Yeah, right now you don't have it, okay?
Okay.
But I try to explain to you how that be done. Okay, let's see. That's what I just copy that one, right? And I paste into here. Now, when you get a star right here, just a command, we don't care whatever command in here, okay? So I delete that. First thing, you get a 4 input. So the first line will be US1, okay? I try to get it bigger so you guys can see. Okay, so the line, the first one, only thing they must be US1. And the next one will be the input. In your circuitry, you say PA01. Then they must be matching. You can see here, PA01. If they different, they're not working. Okay, and this line, you cannot do anything, copy that. Okay. Now, in here, they try to explain to you, 0 at means at the beginning, at means second. What the logic? Okay, if you're looking on the circuitry here, PA01 at the beginning, what logic?
0.
Right here.
Zero.
0. You see that? If you see the waveform, that's a 0, then 1. Okay? 0, then 1. And they will be 1 microsecond for each level. Okay? So they're telling you that will be 0 at the beginning for 1 second, microsecond. How about that one? They 0 for how long?
2 microseconds.
2 micro, and so on. Okay? And now we try to show you how to do. First thing, 0 second, they must be 0. Okay? Then they will be 0 for how long? They be 0 for 1 microsecond. Then they go to what? You can see that they 0 for 1 microsecond. Then they go to 1. Then they repeat the same thing, exactly the same thing. Okay? So that's why you can say using the formula repeat forever. When you repeat forever, then you must be and repeat. And what do you want to repeat? You want to repeat like exactly here. 1 U second for 0, 1 U second for 1. Okay? That means done for PA1. Now, if you do it by yourself, better copy the whole thing here and paste them out. Okay? And change what? US1 now be changed to US2. for second one and change the PA. Before they 1, now they 2. Okay? And then at the beginning for PA2, they will be 0. And how long they be 0? 2 microseconds, they go to 1. Then you can apply same thing. Repeat forever. 2 yield for 0, 2 yield for 1, and repeat. Okay? Then you copy, paste them out, change to UH3. And the name must be changed to PA3. Okay? At the beginning.
And you'd be like, I'm just liking them bitch photos, even though, you know what I mean? Because you're advertising truths and, you know, paid sponsorship.
You.
Yeah. Let me not say that on this fucking
Mute
Zoom.
mute mic.
Okay, at the beginning, they will be 0. For 4 microseconds, they go 1. And they will be repeat forever, same thing. And this one, the last 4, the same thing. If you're looking on your signal here, okay, that will be 2 yield. And that will be 1, 2, 3, 4 yield. And that will be 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay? So after you're done, make sure you must be say only, never say S. This is a project. So they inside the project, if you say S, you get a problem. Okay? Must be only say. Okay? So after you save it, now you go into your in here. Okay? If you want to run the simulation, then you go to Anna digit in here, you can set it up. Okay? Select a transient. Only what you need to change will be changed in here. Final time. This looks like we're using the oscilloscope. The total time maximum you can get will be how many? You can get from 1 yield to maximum. How many yield? Mr. Smith.
I'm sorry, I just heard you. What was that again, Mr. Brown?
What I'm saying is for the setup, the time, final time for the simulation.
It depends.
For this lab.
20 microseconds.
For this lab, what do you think? How many microseconds?
Total number of tests.
Yeah. So you got to have like if you got 16, you need to set it up for like 18.
Right.
Or if you got 12, you set it up for 14. You always set it up for a couple more than what you actually have.
Okay. For that one, you get 16 10. So basically, you want to display around 18.
At least 18.
18 yield. Yield, that's okay. Yield, yes, that's okay. And you can say, okay. Okay, close. And now I try to see, I can simulate it. Okay. Okay, now you go to thread here, take that out, take that out. First thing you want to display the input, 1, 2, 3, 4. And the output will be PC1, PC2. Okay, you see that? When you see you get a red or pink or whatever different color, you get error. They must be green. So now you just go to collect it, click here, toggle cursor. Okay, you see that right here. Okay, we still missing one, right? 1, 2, 3, 4. Okay, I need the 1. Okay, let's see. Cancel that one. Okay, I cancel that guy here. I try to run simulate again. Yeah, we need the one missing. Okay, right here. Check it out, okay? You run PA 1, 2, 3, 4. Output 1, 2. Okay, so you click on cursor toggle here. So at the beginning, you see that PA 1, 0, 0, 0, 0. And output will be PC1 equal 1, PC2 equal 0. Okay, so you can click right here. That's the first one. Okay, then you can go into your here. Okay, P2 equal what? 0, right? And that will be equal 1. And now you're going back in your simulation. Okay, 0 and 1. Then you go to the next one right here. Here, or here, or here, the same. And the next one, output still 0, 1. Okay, then you can go 0, 1 here. Okay, and third one, 1, 2, 3 here. Same thing, still 0, 1. Zero, 1. Okay, number 4. 1, 2, 3, 4. Now will be 0, 0. So 0, 0. Number 5. 0, 0. Number 6. 0, 0. Number 7. 0, 0. Okay. 7. So you can get
5, 6, and 7.
5, 6, 7. Okay, now number 8. Okay, now you get a P210. So now you get a 1 here, 0 here. Okay, then number 9, 0, 0. 0, 9, 10, 0, 0. 9, 10, 11. Let's see. 9, 10, 11. Okay, then you go to 12. Okay, 1, 0. 0, 0. 1, 0. Then 0, 0. Okay, 14, 50. Okay, let's see, we are now here. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 14, 0, 15, 0. Okay. And 1, 0. Okay, so you get a 0 here, 0 here, 0 here, 0 here, and that will be 1. That will be 0. Okay, so you complete that one. You copy that for C here. Control C, copy. Okay, and go to the port. Okay, go to port ABC here. Okay, we're done on that. And now we paste our here. Okay, then you can change it into height. Okay, 0 height what? Tell me what the 0 height, what the data?
0, 1.
0, 1.
1.
Okay. Then the next, I just copy that guy, okay? Copy that, put up here. Make it quick. What happened here? 0 height?
You get 0, X 0, 0.
0, 0. Okay, then I copy this guy. Paste everything here. Okay, and that will be 0 height what?
0, 2.
0,
2.
2. Okay, and that will be 0 height, 0, 0. 0 height, 0, 0. And that will be 0 height, 2, 0, 2, right? Okay, now that's what we done.
What about test 8? Wouldn't that be a 0, 2?
That's number 8. Okay, good.
Yeah.
Thank you. Number 2. Okay, now we're talking about that one. Mass data. What that mean? Mass data means if the pin you're using for your circuitry, then you want to mark with a 1. 1 here, 1 here. And the rest, if you're not using, the mark must be 0. Now convert that number to height. 0 height what?
0, 3.
0, 3. Okay, for the mass, what that means, I explain to you again. when you tell the computer to reading data from port C, then they will be read 8-bit. They don't care what pin you're using, but they will be read 8-bit at a time. Now you must be tell them, okay, I'm using only pin 1 and pin 2, and the other one I don't care. That's why you have to mark them out. Mark mean and get. When you get whatever in here, okay, and you mark with number 3. So basically, that one here, the computer can read 1 or 0, doesn't matter. If you end with 0, no matter what, you get 0. That means you're going to throw that away. I care only 0 here and 1 here. So that's why number 3. That's for the mass number. Okay. And if I'm doing here, I get a wrong in here. Okay. 0 here means it's wrong. Okay, they say 0x03. So that means I'm doing something wrong with my simulation. Let's see, that will be all gate. I'm going to make sure the circuitry. All gate, NAND gate. Okay, exclusive or, and. Okay.
Also, Mr. Pham, you got to make sure you wrote down the right information from your output timing because you were skipping like going 8, 9, 10 real.
Okay. I want to say that will be AND gate. That's correct. Exclusive or here. 1, 2, 4, 5, 6. Okay, it seems to be okay, right?
Yes, it's okay.
Now I go in here. Okay, let's see on that.
I get a different chart that look different to yours.
What test did you get a different one on?
Let's see. Look like
that's number 5.
1, 2, 3.
Okay, number 5. So I try again. 1, 2, 3, 4, 5.
Right there.
It's 1, 0.
2, 3, 4, 5. So I get a 0, 0.
Right. It's supposed to be
0, 1.
1.
Supposed to be 1, 1.
0.
1, 0, because we're using pin 1 and 2, right? Or
4 seconds should be 1, 1. Yeah.
Yeah. Supposed to be 1, 1. But
I did that on my chart. Yeah.
Is it your guy get a 0, 3?
I guess 0. I get 1, 1. So it'd be x times 0, 3. Yeah.
0, 3, right? Number 5.
Yeah.
Right?
Yeah.
Okay. Now, can you see what's wrong in here?
That all looks okay.
Let's see. 1, 2, 3, 4. Okay. And that will be PC1, PC2. I didn't see any wrong. Okay. Who can tell me what can be wrong?
Yeah, the U3 goes to the front pins, not the after pins.
Oh, yeah. Okay. supposed to be from PA02 and PA03, not from the output of the pin 3 and 3 of the U1 and U2.
Okay, let's see. You say some wrong on
pin 7408.
The output of U3.
Okay, I see wrong. I know. This correct or wrong?
Wrong.
Wrong.
Okay. They're supposed to be. Okay, so I did.
I was supposed to go to what? PA2?
Yeah, I know. Okay, so they're supposed to be connected one. Okay.
Mm-hmm.
And the other one goes down.
Let's go here, right?
Yep.
Yep.
Okay, I get it.
No, right.
Okay, we got to send it back to engineering for approval and then have the technician check it again.
Basically. Okay, then try to correct what's wrong.
There you go.
Okay, so we get here. Okay, get a 1, 2,
3,
4, 1, 2.
Okay. There you go. That's the same.
Okay, take you wrong on 5. 1, 2, 3, 4, 5. 1, 1. Okay, 1, 2, 3, 4, 5. 1, 1. 1 and 1.
6 is 1, 1, 2.
Okay, and try to see what else failed. Okay, 5, 6 failed.
It's 1, 1 as well.
1, 1 also, right?
Yes.
5 and 6 here. It will be 1, 1. Okay, so
those would be 0x03s, right?
yeah. Okay, so 6 will be 1, 1. Okay. 6 will be 1, 1. And 8, 9.
8 is 0, 1.
8, 0, 1, right?
9, 10, and 11 are all 1, 1.
Okay, just a minute, okay? Telling me I can correct here. 8, 1, 1. Is it 1, 1?
No, 8 is
6,
0,
1,
2.
7. 0, 0, correct or not?
No, pin 8 is 0 for pin 2, 1 for pin 1.
Okay, 1, 2, 3, 4, 5, 6, 7. 7, 0, 0.
Right.
Okay. 8,
1, 0.
1, 0. Number 8 will be
Got to get back to your Excel.
yeah. Number 8 will be 0, 1, right?
Number 8 is 1.
1.
Well, yeah. 0 for pin 2, 1 for pin 1.
Yeah. And number 9.
1, 1.
Okay, just tell me. Number 9, 1, 1. Number 10.
1, 1.
1, 1. 11.
1, 1.
1, 1. 12.
1, 0.
Okay. 13.
1, 1.
14.
1, 1.
15.
0, 0.
16.
0, 1.
0, 1.
Can you share your screen? Can you share your screen, the table one?
No, just a minute. Okay. That one.
The last one, hit enter, and then you get a 1 for that. Right now, you still fail.
That's 0, 1, right?
Yep, there you go. You got a pass now.
Okay, see that right here.
Yeah.
Pass. Perfect.
All right, Mr. Pham, we can move you on to tech 2.
Copy that guy. Try again. Go to port AC here. Paste them out again. Okay. Oh, I did wrong. Undo. Okay. I paste them out here. Okay, so 0, 1, 0, 1, 0, 1, 0, 0, 0, 3, 3, 1, 1, 0, 3. Okay, and now I copy that guy. Control C, paste them out here. Here. That one. 1, 2, 3 here. That one. And that will be 1, 1. Okay.
Can I ask a question here? Number 8 on test number 8, should that be 0x01? You got 0x02.
Okay.
Test number 8.
Yeah.
0x01, right?
Yeah.
Okay. So we done on that one. And now we want to get this one. 0x 0, 2. 0x
03. No, I mean 4. After that.
0x 04.
Yeah.
5.
And 6. 7.
0x7.
8. 9.
Right?
Right. Now you're doing the A, B, C, D.
Okay, so you see that they parted. So that is a completely for the Excel file. So you get any question? Okay. Now I go back to I quickly done on this one. How many input? We know how many input, right? 4. How many output?
2.
2. How many gate? 5, right?
Gates in the circuit?
How many IC? 4. Pin connect to 5 volt, 14. Connect to route, 7. How many gate inside it? IC 4. To see part that. Okay? And I going back here. Okay? You get it part. Then now what you need to do, upload the file. Okay? That is completely done for the Excel.
You got to put your name in, Mr. Pham, so you can get credit.
Okay. So any question when you get a schematic?
I have a question, but it's about the very first step when we want to do the simulation.
Huh?
Can I ask that now?
Yeah.
So I'm not getting any waveform, and I'm guessing that I'm doing something wrong in the setup or the simulation. Can you go over what we do after we draw the circuit one more time until the step that we get the traces? Because all I'm getting is like flat lines.
Now, can you share your?
Yes.
Okay, that's easy to find out what's going on. Okay, I stop share here. So now you can share. Then we can tell you what draw.
Did you type your input patterns into the notepad?
I think so. Oh, I didn't edit them correctly. The file that we save as dlab.stm, I don't think I edited that correctly. So never mind. Thank you.
Don't be afraid to come back.
Yeah, you see, that's wrong from input also output.
Yeah, I would have to go over every line to make sure, because I know I just forgot to edit a few lines. So I'll go over it, and then if it doesn't work, I'll ask.
Okay, if you want it, I can upload that notepad for you guys.
Yes, please.
Okay, let's see.
Okay.
This is the one, right? That's the one we just did it. Okay, so you can stop there. I can try to get into the web and try to upload this file. And you just copy it, paste it into your, okay? Let's see.
I can share mine right now as well, Mr. Pham. I have it all written out if you want.
Yay, Adam, we want to see it.
Is that all right, Mr. Pham? Or
Yeah,
you want to...
go ahead.
Okay.
Adam's fast as lightning. All right.
You know what? I think I just lied to you. I don't have it up anymore. I closed it out. I'm sorry. My bad.
What is that, Adam? Is that yours with the 1516 on here?
Yeah, I already finished the programming. I just uploaded it to the website.
Well, you should still have it on your board, your whatchamacallit.
I probably have it somewhere. Give me a second. Let me try to find it.
Hey, Adam, while you're doing that, do you save your stuff on like a memory stick or something?
Yeah, yep, I have it somewhere. That's where I'm looking right now on for it.
Okay, so I will be upload that include file, okay, on to the assignment tech two. Then you can open, copy it, you can do it. However, what I want to do, the red for today, we
I
can
just found it, Mr. Pham.
program done. Okay.
Hey, Mr. Pham, he just found it.
Can you guys see that?
Yeah, I see it. That's the same thing what we get it.
Yes, sir.
Okay. Yep. Now, I want you to looking into the quiz number 4. I want to explain to you. Try to make sure you understand that. Okay, can you stop share, okay? Now, you already download the quiz number 4.
Hey, Mr. Pham, I downloaded it, but it won't let me click into the box and put an answer or anything in the box.
That's okay now. I given you this signal. I want you to writing for includes. I given you example here. This is a PA01. Then the first line after event 1 here.
Mr. Pham, you need to share the screen.
Oh, not share the screen yet. Sorry.
That's okay.
Okay, you get the signal. And we want to make sure you're able to doing your writing in an include file. First thing is you understand the first block here. Oh. Okay, so that must be a name, PA1. And now, at the first 0 second, at the beginning, what logic here?
0.
Okay. Now, you can tell me, okay? At the beginning, what logic here?
1.
Sorry. Yeah, I'm sorry. 1. You're right. 1.
You see that? That's the answer right here. 1. Oh, man.
Hey, Mr. Pham, like I said, just to let you know, this thing that you gave us for this timing, if I click into the box, it won't allow me to put in like an answer. I guess that's what you wanted, correct?
Is it you already download this one?
Yeah, and when I click on it, it don't work. It don't let you write in the box.
Oh, they not let you write in the box here?
Right.
It's a spreadsheet, so you cannot do that. You have to use the pen and then just write in it, or print it out and write it.
Yeah, because like the other ones that he did, when you clicked on them, they would let you write in the box. But this one, for some reason, it won't.
Okay, I want to see what happened. Okay, now, if I want to write in here, okay, let's see, they allow me to do it? No. Oh. Okay, so somehow I don't understand why they not let me writing in here.
Because that's what you wanted us to do, correct, Mr. Pham?
Okay, I know why. That only thing is you have to bring it out.
Okay.
Or you can just draw a table on that slide, Mr. Smith. Just insert a table next to it.
I'll do it later on by hand. I'm not as good as some of you guys on the computer.
I'm so old, I still have the paper copy we got in the classroom way back when we used to go to school.
Okay, now I try to explain to you here. Okay, we don't care that one. At the beginning, 0 second. That means right here at the beginning. What logic? That's what I say, 1, right?
Correct.
Yes, sir.
Okay, now the problem is they won for how long?
2 microseconds.
That means they're here, 2 microseconds. That's right here, same thing. They won for 2 microseconds. Then they go where?
0.
They go 0. So that's why you get 0 here. And they stayed up 0 for how long?
1 microsecond.
That's why you get 1 microsecond here. Then they go to
1.
So that's why they go to 1. How long they stay 1?
1 microsecond.
1 microsecond, then they go to
0.
For how long?
2 microseconds.
Then they go back to
1.
You see that on this one, the signal is not repeated same. You cannot using repeat forever. Based on what they given to you, you're able to get this output here. Okay? And now, on this one, then you already know. They will be repeated, right? Same thing. So that's why at the beginning, they will be 1. So that's why you get 1. Okay? Then they won for 1 microsecond, then they go 0. That 1 yield, then they go to 0. Okay? And they repeat again. Try keep doing the same. Okay? So that's why you have to using repeat forever. Okay? Repeat 1, 0, then end repeat. Okay? That's why they say repeat forever. You enter, okay, 1 yield for 1 yield for 0 and repeat.
Hey, Mr. Pham, I got a question for you.
Yeah.
You know, like on that last one you did, PA2, since it's a repeat forever, the repeats forevers, is it a good idea to put them first? Maybe like make them PA1 and then put something else as PA2? That wouldn't change anything, would it?
You mean a PA1 or PA2?
Yeah, well, I'm saying the repeat forever. Would it be a good idea to always put that first, like as PA1? I'm asking.
How come you get a PA1 in this one?
No.
I think it would change it if you depending on what you had PA1 and or 2 attached to. You know what I'm saying?
Yeah. Okay. Yeah, because I was thinking if you put the repeat forever first, then anything else you could put after it, and then if you had to copy paste, you could copy from that first one, which is like PA1, because it's a repeat forever. It's a generic one.
But depending on, sometimes the signal will be go 0 to 1, then
0 to 2.
Yeah, keep instead they 1 here, 0 here, and they can 0 then 1. Then repeat will be different.
No, I was just wondering if you could do that, if it would affect the circuit or anything.
Now, if you're not doing it right on this timing, they're not working.
Okay. Thank you, sir.
Now, pin number 3 on that one here. First one, you see, you will be logic 0, right? So that's right here, 0 at, they will be logic 0. They 0 for how long?
Half a microsecond.
That's why you get 0.5 U. Then they go to
1.
How long they stay 1?
3.5.
1, 2, 3, and this a half. So 3.5 microsecond they go low. And they stay in 0.5 microsecond, they go to 1. It's right here, okay? 0.5 U, they go to 1, okay? And that after 0.5 U, they go into 0, and they 0 forever, okay? Okay, now on this one. At the beginning, you get logic 1. 4.5 U, then they go 0. That one here, after 0.5 U, they go 0. And they will be 0 for 3.5 U, then go back to 1. Okay? And they stay 1 here for 1.5 U, then they go to 0. Okay? And they will be stay in 0.5 U, then they go back to 1.
Mm-hmm.
The thing is, this time we change the way to teaching, but I never pay attention on how we'll be helping you to do this thing. Next one will be more, much better, okay? Still the same thing here, but I get the way so we can do better. But up to this point, you get the schematic, okay? And you need to run the CP-SPI simulation to get the output. Until then you have to get completely your output for the circuitry. You have to put data into port A or port B or port C, depending on the circuit, which port they're using. Then you have to convert into the hexadecimal. If they pass everything, that means we done for the first part of your DLAB. On the DLAB will be doing the same thing. However, most of the lab will be not using simulation. The thing is, they don't have a part in the simulation. The simulation for student, okay? if we can buy more, you know, simulation like the other guy, he using a PSPI 14, they have to pay something, okay? Then you can run a little more, but that doesn't matter to me. All of the lecture on the digital is not too much. The next step we will be learning about the flip-flop, okay? That will be a little more detailed. But after that, everything will be just an IC. We'll be learning about the counter, decoder, encoder, you know, serial to parallel converter, or so on. But that only IC. You cannot simulate it, okay? We don't care simulate it. If you understand how they work, then you can do the lab. But the main point will be the lab. I will be given to you. Another lab will be substitute for this one, the lab one. I want you to make sure you can get it path to upload it. This one, you don't have to upload it. I will replay by another one, okay? For you guys start doing from the beginning. The program that's easy, okay? If you know how to do it, we just copy, paste, okay? And after you compiling to running, I given you an example here. Okay, let's see. Just a minute. Be one here. Okay, let's see. Okay, I will share that one ready, okay. Okay, you see the program?
Yes.
Okay,
Yes, sir.
now, you can see I can run. First thing you have to build, compile, okay? Everything, make sure they get no error. You want to run it to start without debugging. You see that? When we run, they fail, they say fail test number 1. Test title, whatever test title we put in, test 01. Now, expect data, what that means?
Means the data that you're going to read from port C.
Right, that's the data we wanted. Then they say measure data. This is the data the computer read. They read on 0. So you see they failed the thing they did the first bit, you want 1. However, computer made a 0, so that's why they fail. Okay? And pick up, that means what caused the problem. Right now we say E1, E2, E3, E4. That's on the for C, on the Excel. Okay? Then you press any key. You can see. That goes to number 2. You wanted 1. but they read 0. You understand why they read on 0? The thing is we have a no hardware. We supposed to connect the text box into the computer and into your circuit board. Okay? Right now you get nothing. So that's why the computer read on 0. And same thing. Now this one, how come they say part?
Because your expected data is 0.
Yeah, the reason you want output to be 0. Okay? And so on. Now, finally, fail. So they must be part. That means you complete the lab. So for now, after you done, you compile everything, no error. Then you have to upload the CPP file. That means upload this file. Okay? Normally the people make easy. First thing they say, Control A, select everything. Then you can copy to the text file, Notepad, and you can upload Notepad. Okay? If the people really understand, then you can go into the project for this DLAB, looking for CPP file. Then you can upload that one also.
It's also
way you can do. Highlight everything, copy, paste it into the text file. Then upload text file. Okay? When we get your file, we will run with the real hardware. If they pass, that means you complete it. Okay? If it fail, we can tell you try to correct it. Why they fail. So we already get the circuitry already built. Okay? Or we can build a new one. Doesn't matter. But we get the part, we get the system at home. We can do it. So every time you upload it, and when we're working with your guy, okay, and we run each program will be run on the Zoom. Like I say, I run the program from Mr. Smith, okay? If it passed, he passed. If it failed, then find out why it failed on your software. When we return into the class, then you will be built and test, okay? So now, if you done for this thing, you've done almost over 50%. When we get the board, you can build and run it, make sure they pass. That's what you get credit for, okay? So when you return into the lab, you just get the circuit board, the part, and everything needs to build the board. You can take home and build it, okay? And you can come into the class, just verify to run it. Make sure they pass. That is the whole process for digital lab. Any question?
I was just going to point out, Mr. Pham, I found it really helpful if when you're finished writing your programming to also copy and paste it into an additional worksheet in your Excel so that you have everything together. You have your programming with your Excel so you can look at everything all at once.
Okay, perfect. I agree. That means after you're done, you Control A, right? On that one. Okay? And basically Control A, then you copy and you paste into your Excel file. Okay? So that's why I have to prepare again for the DLAB01, a new one, okay, with the one worksheet okay, for, okay, program. So if you're looking on that one here, you can see there's a DLAB first one. Next one will be quiz here. Next one will be port ABC here. And we will be create one more, okay? One more here. And I say test program, okay? Then after you get the test program, and you can control V, okay, to pass them in here, okay? Then you upload Excel file, then we get everything. Okay, and then something else. Okay, Mr. Smith, you see my MSIM 7 for bridge rectify.
Where's it at?
I already given to you the assignment, okay? Bridge rectify here, okay? You see that?
Yeah.
So make sure you're able to get that.
Where did you send it to?
What?
Where did you send it to?
That on the assignment Tech 1.
Okay.
Mr. Pham, I thought you told Tech 2 that we're not responsible for Tech 1 assignment.
No. It's something
you don't have to do anything.
Oh, is this just a Mr. Smith thing?
Yeah.
Or if you want to do it, you can do it as well.
Right,
oh,
right.
Just for fun, yeah.
That's what I say, okay?
Okay, thank you.
If the last time you didn't see that kind of the MSIM 7, right? Simulation, then you can do, but you don't have to upload, okay? The thing is, myself, I try to improve every time, okay? So you can see last semester will be a different from this semester, even handout or the quiz or the homework. But Tech 2, your guy, you already get through Tech 1. So you don't have to do upload any, okay? But that would be good if you get the time, you can do it, okay?
Hey, Mr. Pham,
yeah.
Where did you send it to?
Where?
Yeah, where did you send it to? I'm trying to find it.
I think he just said it's on the website.
It's assignment 11.
Yeah,
that one here, you don't know. Okay, I show you. Quickly. You go into our website, right?
Okay.
And you go take one. Right here.
Hey, that was you, Mr. Smith.
Bridge rectify. Okay?
Okay, let me see if I can find it.
You can double click. They bring it up the same thing. Okay?
Okay, I might get the up.
Yeah, you can look into that. Okay, so anyway, good night, okay?
All right.
Thank you, Mr. Pham.
Yeah, we'll talk to you guys tomorrow.
Thank you.
You are welcome.
Thank you.